And now we have the lost write scenario, and this requires a little bit more lateral thinking thing. So as so far, the beginning, everything as before, we decide to change something to the B, and it's read in, and oh, it's an A we've got, so we've got to work out the A to B changes. We do the B changes, and we write it to disk, or so we thought. It actually didn't arrive at disk. It just disappeared into thin air. And at that point, if you try to use the data, you will just see the old data once it's aged out of the cache. So that's just simple lost data, and yes, a normal recovery would recover it, because then it would repeat the write, and the presumption is it would work the second time round. And likewise, when we do the next data change, you say we want to change the block to C now. Think of it as another row where we do an update, another row in the same block. So we just read in the block, and of course we read in the A copy of the block, and we work out how to change that second row, which makes it the C version. Now, compared to the first slide, you see that we have the redo vectors A to B, and this time around we have the A to C, where before we had B to C, and this is where the things gets rather fatal. But nevertheless, the C is generated and the C is written to disk. And this is what is a lost write, because we don't have the B on the disk. It's never been on the disk. And what we now have are two redo vectors that show divergent timelines, where we started a day, and in one of them, the man traveled back in time, and the other one, it didn't type stuff. So we've got an A to B location and an A to C. That's divergent timelines. The B version is only stored in the redo log. If we discovered this problem at an early stage here, we could say, okay, stop the database, do a crash or media recovery so that the B gets on disk. At this point, the C version can only exist if the B version never existed. This is the important thing. Now, I know by turning the B and the C, you think, well, that doesn't matter because you've overwritten the B. Now, think of the B as a version of the block. There were two rows. One of them had a B in it, and the other row had a C in it. So we never get the B row anymore. It's lost. And there is one happy circumstance that might happen. If the second write came very quickly, then the B wouldn't have aged out of the cache yet, and we would generate the B to C, in which case we would lose the lost write. And as we know, two negatives make a positive. Now, standby or recovery in the lost write situation fails. So we start off as before, we read in the redo vector, we read in the A block, we generate the B block, and we may or may not write it to disk. That's irrelevant in this case, but at this point, we want to, redo vector says the next change is to go from A to C. But we've got a B block in our hand, either by having read it from disk or because it's still in the cache, because we assume that the recovery went well with its first write there. And at that point, we stop totally. There's just no way past it. And that's the pictorial thing. Then we can talk about the likely causes of a lost write. The obvious one is the hardware is malfunctioning. The other one is the software might be malfunctioning. In particular, if you think about it these days, when I write a block to disk, I write it at an offset in a file. The file has an offset on the disk has been virtualized, has an offset from the repository has an offset from the SAN disk where it is, which has a remap to another set of the disks. And in all of those things, somewhere it messes up. A database issues zillions of writes, or billions of billions, as somebody used to say a few years ago. And even with all those parity and checksums, which do catch single errors, double and triple errors sometimes occur, and it slips through the cracks. By the way, all of this is because I was at the customer side, where after much debugging of why the standby wasn't continuing anymore, we discovered we had a lost write at our hands. So in Oracle, when we have a normal Oracle, when we have a lost write, everything works fine. The first transaction works fine, except that we'll never see that data again. The second transaction works fine too. But we just have this one lost write problem, and we will first discover it, if we haven't done anything special, when we try and do recovery on it. If you have a standby, physical standby database, then that will discover the error when it processes that second redo. And at that point, it is too late. We've lost the, we have the two divergent timelines. The fact that we've started the second transaction on the block is where we lose it. It's not on the writes as such. Password, it has nothing to do with me. It popped up from your thing. Yeah. Right. So then with the standby, Oracle has this thing called lost write detection. And the init parameter calls lost write protection, except it doesn't protect it all it helps you detect it. But you know, marketing people like to give it good names. And what it does when you enable it is it adds into the redo vector whenever it does a read that I've read this block. And that means that when your primary is working normally, and we've done the first write where it was lost, so the disk only contains the A, then when we do a read operation on it, the primary says, oh, I'm reading this block, it contains an A, and that goes across on the redo stream. And on the standby, where we presume it received the redo stream initially with the A to B change and wrote to B successfully, it repeats the same read and says, but I get a B and you get an A, so between us, we agree that we've got lost the write somewhere. Might have been that the standby lost the write, I suppose, from there was a B years before, but typically then it's on the primary. So this works because the lost write protection does a comparison read on a copy of the data where we have done the same writes. In this case, in a standby usually. If you don't have a physical standby, you could of course just do lots of recovery tests. We notice there's a small Achilles heel with a lost write detection is that it's dependent on the usage pattern of the block. If you write it once and never ever read it again, nobody cares. I mean, we're not going to detect it, but we're not going to miss it either. In fact, you might wonder why you made a change to start off with. So people ask me a lot, but if you do this, if we do the second write before afterwards, then we don't, no, it doesn't work that way. Once we have the lost write, because we've got two divergent redo vectors, we aren't going to get out of this. So once people have started doing a second modification to the block, we're sort of in a bad state. So the intention is with lost write detection is to detect it as early as possible, and then immediately slam the emergency brake, stop the database and do recovery. So in 18C, Oracle says they now have lost write detection without a standby. And that works by the fact that you choose a few tables instead of the whole database, which is of course more optional. And then it will make a secondary table space of those tables where it will do writes to. So it duplicates the data. So a quick repetition is the bad and the good. If you have a lost write and the block is read, then if you don't have lost write detection, then at the time when you do a second change to the block, you will go down the path of no return. But if you do have lost write detection, you can slam on the brakes, re-establish the lost block, and then carry on. And for those that take the slideshows, there's some Oracle has some nice little screen drawings where they show demos of this, which you can just view and look at them. But otherwise, for my part, I'm finished with this quick intro of lost write detection. And if you have any questions, of course, I'll be out of here in a short moment.
What about backup validate? Backup validate find those lost writes?
No, because that only works on the backup sets. That they're internally consistent. So it doesn't happen. It doesn't help you there. I mean, if you restore before the first write, then you can recover the B block, but then you cannot apply the C change because that presumed an A block, and you don't have a backup of that. And that's why you end up in this split timeline, and you can't get out of it without sacrificing something. Well, thank you very much.